Hello friends, welcome back to the revision of chapter 1 real numbers of grade 10 NCERT syllabus. In first video we discussed about the revision of chapter 1 real numbers, that is the part 1. Now I am going with the part 2. In this video I am explaining and also revising the concepts of second exercise, that is exercise 1.2 of chapter 1 real numbers. In this exercise 2 mainly we have the topic irrational numbers. So we need to prove the given number as irrational number. For example, see here how to prove the given number root 2 is an irrational number. If you want to prove this root 2 is an irrational number, in the 9th grade we proved that root 2 is non-terminating number and non-repeating number. By decimal expansion of irrational of a number, we proved it's a irrational number. So if you want to say the given number is irrational number in decimal, the decimal expansion of a number is non-terminating and not repeating, we can say that it is a irrational number. But in grade 10 we will not prove by using decimal expansion, we will prove by using contradiction method. See what is the meaning of contradiction method. Contradiction, I am saying something is true. If you are saying that it is not true, that is contradiction. If someone is saying that true, if you are opposing that we can call it as contradiction. Now here by using contradiction method we will prove that root 2 is an irrational number. If you want to prove root 2 is an irrational number, first we will assume that root 2 is a rational number. So rational number and irrational numbers are different, right? So I will take that, I will assume that root 2 is a rational number. At last I will say that root 2 is not a rational number. If a number in real numbers, if a number is not a rational number, it's an irrational number. This is the contradiction method for irrational number in this chapter. Now first we need to assume this root 2 is a rational number. Now I am writing the solution. I will write the short form. I will explain. I will show the complete procedure, because as I am writing here only the important steps. Okay. And first I am assuming that root 2 is a rational number. Okay. Let us assume that root 2 is a rational number. If a number is rational, how can you write? We know that if a number can be written as in the form of p by q, it is a rational number. Now if you want to take root 2 is a rational number, we are taking that root 2 is equal to a by b, where here a comma b are co-primes. I am taking co-primes. What is the meaning of co-prime here? If numbers a and b doesn't have any common factors, if a number is not having common factor except 1, we can say that co-primes. This is the important point here, because here we are taking that a and b are co-primes. At last we will say that a and b are not co-primes, so that it is wrong. What we have assumed, that's wrong. That's why you can remember that a comma b are co-primes. If a comma b are co-primes, so a and b are not having any common factor except 1. So now I am taking that a comma b are co-primes and root 2 is equal to a by b. That is the definition of rational number. Now to prove a and b are having except 1 some other common factors, I am squaring on both sides. Squaring on both sides. SOBS is squaring on both sides. If you will square on both sides, root 2 whole square is equal to a by b whole square. A by b whole square. So root 2 whole square is 2, a square by b square. Here a by b whole square, we can write it a by b whole power m as a power m by b power n. Like that, root 2 whole square is 2, a by b whole square is nothing but a square by b square. Next I am writing b square is equal to a square by 2. I transpose this 2 and b square. I interchange, I switch these 2. So if I will bring this b square to left side, it will go to the numerator only single term. Here we have 2. If you transpose to right side, it will go to the denominator. So a square by 2. Before this we have a theorem. Let p be a prime number. If one number is prime number divides a square. So prime number divides square of any number, it also divides that number. So from that I am writing the theorem now. Let p be a prime number. P be a prime number if p divides a square. P divides a square, then p also divides a. P also divides a. Let P be, this is the theorem 1.2 in your textbook. P be a prime number. If P divides A square, then P also divides A. Now, in the same way we can say here 2 is a prime number, 2 divides A square, then 2 also divides A. Now I am writing directly 2 divides A. So yeah, actually you should write it. 2 is the prime number. If 2 divides A square, then 2 also divides A. Directly I am writing here. So when you are writing the exam, you can write clearly step by step. Now I am taking this equation is 1 because here I am assuming that I am taking that 2 divides A. In the same way we need to prove this 2 divides and also along with A, B also. So for that I am taking A is equal to 2C. Here 2 divides A. We want to prove that 2 divides B. For that I am taking A is equal to 2C. In place of this A, I will substitute 2C. See now why I am taking 2C. Here the given question is root 2. So one reason is I am taking 2 here. Okay. So next example, if it is root 3, you can take in place of 2, 3. Like A is equal to 3C. If it is root 5, A is equal to 5C. If it is root 7, A is equal to 7C. 1. Next one is C. C, instead of C, you can take any other variable. Just already we have A and B, 2 variables. The third variable I am taking it as C. That's it. There is no other reason. Directly I am taking A is equal to 2C. Now substitute A value in equation 1. We have equation 1. B square is equal to A square by 2. So I am substituting in place of A this 2C value in equation 1. We will get B square is equal to 2C whole square by 2. I am substituting in equation 1 in place of A 2C. Now simplify it. B square is equal to 2C whole square. 2 square is 4 and C square by 2. So 2 ones are 2 twos are. Now we can write it C square is equal to B square by 2. If you will observe this step and compare this with equation 1. Here we have B square is equal to A square by 2. Here C square is equal to B square by 2. Can we say same like this statement? Let P be a prime number, P divides A square, P divides A. That statement I am using once again. If 2 is a prime number, we know that 2 is the prime number. 2 divides B square. Then 2 also divides B. Directly I am writing 2 also divides B. Now take these two statements. First statement, second statement. 2 divides A, 2 also divides B. Means what? 2 divides both A and B. 2 divides both A and B. Because here 2 divides A, means A is divided by 2. Here B is divided by 2. 2 divides both A and B. Means what? 2 is the common factor of A and B. 2 is the common factor of A and B. But what we have assumed here, we assume that there is no common factor. That means A and B are co-primes we have taken. There is no common factor between A and B. But we have here, there is a common factor 2 for A and B. So now we can say that A and B are not co-primes. Not co-primes. So you can write the conclusion now. Actually we have taken A and B are co-primes, but here we got A and B are not co-primes. So it contradicts to our fact. It contradicts to the fact. So our assumption is wrong. So our assumption is wrong. What is the assumption? Our assumption is root 2 is a rational number. Now we are saying that our assumption is wrong. If our assumption is wrong, we can say that next two steps only, conclusion. Root 2 is not a rational number. What is our assumption? Our assumption is root 2 is a rational number. We are taking that our assumption is wrong. So root 2 is not a rational number. Whatever assumed, it is wrong. If number is not a rational number, it's an irrational number. Write the conclusion. If a number is not a rational number, we can say that it is an irrational number. Therefore, root 2 is an irrational number. Clear? Now, like this, we can prove root 3 is an irrational number, root 5 is an irrational number, root 7 is an irrational number. In the same way, you can prove it. Just only you have to change the number. In place of 2, you can take 3, 5 or 7. Next, here in place of here we are taking that a is equal to 2c. For root 3, we will take a is equal to 3c. For root 5, a is equal to 5c. And root 7, a is equal to 5c. At last, the complete procedure is same. Only in just number will change. The procedure will be as it is. So follow this method and also procedure to prove that the given number is irrational number. Now, after this, we have a question. The combination of rational and irrational is a rational number. That I will explain in the, as next one more example. First, learn how to prove given number, given single number, that is root 2, root 3, root 5, root 7 are irrational numbers. Next, I am taking two more examples. This 5 minus root 3 is textbook example. This is one more other example. So here, if you want to prove 5 minus root 3 is an irrational number, here you should remember that how to prove the root 2 is an irrational number, because when the question is asking for 3 marks, these questions are asking for 3 marks. In this question you need to prove root 3 is an irrational number, and in this question prove that root 5 is an irrational number. The same question is asking for 2 marks. 2 marks, no need to prove again root 3 and root 5 are irrational numbers, or in some cases in the question it will be given that if root 3 is an irrational number, or given that root 3 is an irrational number, then prove 5 minus root 3 is an irrational number. If already root 3 is an irrational number, it's given in the question, no need to prove again. Directly you can take it from given it is an irrational number. Now, when the question is like this, I told you before in the beginning of this video, first we need to assume the given number is rational number. That is common for every irrational number question. Even this one also we can take it 5 minus root 3 is a rational number. After that, first 1 or 2 steps are common for every question, and last 4 to 5 steps also fixed common. So now remaining steps I am explaining, only short form I am explaining. The beginning of the question and the ending of the question you can write it by your own. Okay, if you want you can once again you can go through the beginning of this video how I proved root 2 is an irrational number. Same steps you can write. First 2 steps are same, last 4 steps are same. Now here first I am taking this 5 minus root 3 is a rational number. What is the rational number? We have to take that the given number is in the form of p by q, or I am taking here a by b. What a and b here? A comma b are co-primes. Actually you should take that a comma b are integers. So co-primes also integers, right? So co-primes also numbers from the integers only. So I am taking integers, and also which doesn't have any common factor except 1. Now we will take 5 minus root 3 is equal to a by b. Here in this questions we want to write irrational number in terms of other rational numbers. For that I am keeping irrational number to one side. I am taking that root 3 minus root 3 one side, and remaining rational numbers I am taking to other side. So only one rational number we have plus 5. This will take to right side, will become minus 5. So simplify it. Root 3 is equal to, take LCM for this. LCM is b. Here a minus 5b is the right side form. Next we have here minus, we need to remove even this. Root 3 is equal to, we can say that a minus 5b by minus b directly, or you can multiply whole expression or fraction with a minus. So you can write even this as, when you are multiplying, minus into a is minus a, minus into minus plus. Now we can write it as 5b minus a by b. Now root 3 is equal to 5b minus a by b. Here what are the numbers? What these numbers are? A, b, 5b are integers, right? 5b are integers. Now root 3 is in the form of p by q. If a number is in the form of p by q, we can say it is a rational number. So, but we already know that root 3 is an irrational number. You can prove how it is irrational number. Then last conclusion for this question: if root 3 is an irrational number, then we can say that 5 minus root 3 is also an irrational number. After this you need to continue. So root 3 is in the form of p by q. Now what we can say, if a number is in the form of p by q, root 3 is a rational number. Root 3 is a rational number. So after this you can write it, but we know that it is if root 3 is a rational number, but we know that root 3 is not a rational number, you can write at the end, but we know that root 3 is an irrational number. If root 3 is an irrational number, then the given number, that is 5 minus root 3, is also an irrational number. Like this, you can write the conclusion for this question. In the same way, I am explaining for this question 2 plus 3 root 5. Here for 2 plus 3 root 5 also, we will assume that 2 plus 3 root 5 is a rational number. If 2 plus 3 root 5 is a rational number, we can say that 2 plus 3 root 5 is equal to a by b. I think you know the reason what you will write here. In place of this blank, we can write it a and b are co-primes like this. Okay. Next, we want to write root 5 in terms of rational number. For that, I am keeping this 3 root 5 term as it is left side. I am transposing plus 2 to right side. Then it will become a minus b, a by b minus 2. Here plus 2 we have to transpose to right side, it will become minus 2. So 3 root 5 is equal to LCM b, a minus 2 into b, 2b. Next root 5 is equal to a minus 2b by, here 3 is multiplying left side, if you transpose to right side we will go to the denominator, that is 3 into b, 3b. Now what we will write here? Here a minus 2b, 3b are integers. Now continue the same process. Here we have written here in the previous one a, b and 5 are the integers. Now here root 3 is in the form of p by q. Here we will write root 5 is in the form of p by q. Root 5 is a rational number, but we know that root 5 is an irrational number. If root 5 is an irrational number, then 2 plus 3 root 5 is also an irrational number. And one more method of this, one more question we have in the textbook, that is 1 by root 2. Prove that 1 by root 2 is an irrational number. If you want to prove 1 by root 2 is an irrational number, we will take 1 by root 2 is equal to b by a, because to already we learned how to prove root 2 is an irrational number. By solving the question in the same way, I am taking 1 by root 2 is equal to b by a. From this, if you cross multiply, what you will get? Root 2 is equal to a by b. How you proved the question root 2 is an irrational number? In the same way, you can prove 1 by root 2 also irrational number by taking, instead of 1 by root 2 a by b, I am taking here 1 by root 2 is equal to b by a. From that we will get root 2 is equal to a by b. You can follow the same procedure. So along with this, we have a combination of two irrational numbers like root 2 plus root 3. Prove that root 2 plus root 3. These are questions you don't have in the textbook, but in the exam point of view, they will ask you how to prove root 2 plus root 3 is an irrational number. If you want to prove root 2 plus root 3 is an irrational number, take root 2 plus root 3 is equal to a by b. Root 3 is equal to a by b minus root 2. You can take it, root 3 is equal to a by b minus root 2. So after that you can take LCM, square on both sides. When you have two irrational numbers in the question, we need to square on both sides. This you have to remember. So like this, you can prove the given questions as irrational numbers. In next video, I will give you some list of questions which are important for exam point of view. Once go through that video and try to complete this revision of the chapter 1 real numbers. Thank you.